Hello, thank you for watching the video demonstration of our Raspberry Pi project. I'm Matt Danielson. I'm also in a group with Purana Goki and Kai Yearling. So the goal of our project was to create a programming game where students would be able to compete against each other by submitting code to a central server and having that server time it and create a leaderboard. So the way that this works is we use the Raspberry Pi as the server, and each student would be a client able to connect to that server in order to submit their code. So we wrote the code in Python. There's three classes to go over. The first one is this submission handler.py. What this class does is it takes the files that are sent to the server, it unpacks them, and it processes them, gives them a time, so that way we can figure out who was the fastest coder. So this first one, setup submission, it's given the path to a directory that we've created on the Python server. This directory has protected permissions, so that way the clients are only able to submit their file, they're not able to modify any files on the server. This submission is going to be sent in zip or tar format, and it's going to be coded in C. So after the file is unpacked in zip and tar format, the Python code is going to make the file, and then it's going to tell you that it was successfully unpacked. So now you will have a functioning binary. The other important method in this class is the run submission. So this one takes in the submission binary that the student was able to submit, and it also takes in a path to a challenge. This challenge is going to be a problem that the programming competition can set. For example, doing a depth first search, doing a merge sort on an array, or any other thing that you would be able to time and have students compete against each other. So the run submission method tells you that you are attempting the challenge. It's going to find the challenge output stored on the server to be able to determine what the correct answer should be if the student got it right. It's then going to set up a number of repetitions, however many the server would like, to get an average runtime of the program, and in that way the user will know that their program was done several times and it's an average runtime instead of a one-time runtime. So the server is going to start timing. It's then going to run the submission binary, and then it's going to end the time. If the correct answer of the challenge problem is equal to what the user submitted, then it will append the runtime to this array of times that we have. Otherwise, it's going to tell you that you did not get the correct answer. So I'm going to compute the average runtime out of the array of times and return that to the server. Next important class to go over is leaderboard.py. This method, this class, is what will display the results of the test to the user. So some of the methods that this has is you can insert a new time with the user's initials. You can retrieve that user's time out of the current leaderboard, and you can also see what the top 5 of the leaderboard currently are. The last main class, this is going to be what runs the rest of the program, is server.py. Server.py uses the socket module, which is useful for networking. First thing we're going to do is we're going to establish a port that the user is going to listen on. This is all on the same network. It's going to open a socket to that port, and then there's a method. It's going to start listening, and it's going to say waiting for a connection. So this could take up to 5 different clients. You can always add more to this if that is what you desire. This is going to be for one thread of clients, so that way you can connect to multiple clients at the same time. It's got a data buffer for receiving messages from the client, and then it also will take that message, and depending on what the message is, it will respond back with its own reply. So if we come down here and we look at the main part of our program, first thing we're going to do is create a new leaderboard. We put in some names here, well, initials, just for fun, so that way you can get an idea of what this would look like with many students using it. There is a set of checked files, so that way it will not keep running the same files over and over again. And then, while it is listening, it's going to accept a new connection, start a new thread for that connection, and then execute this loop. So the Pi program will keep running as long as the Pi is connected to the internet and powered on. So that way you can have a full-time server ready to accept connections at any time. So what it's going to do is it's going to see if the file that the user submitted has been added. So it's going to check all the files in the special directory that we talked about that has protected permissions, and it's going to check if there's any new ones. If there is, it's going to unpack it, just like we talked about in Submission Handler, and then it's going to calculate the time of that submission. It's going to input the user's initials into the leaderboard, and they'll be ready for the next run. So let's see how it works. On the right over here, this is my personal computer. This will be acting as the client. On the left, we have the Raspberry Pi that is acting as the server. So if we look in the Raspberry Pi directory, first thing we notice is we've got all of our code that's going to run it. So we have server.py, leaderboard.py, and submissionhandler.py. We also have the directory challenges where the correct outputs live. So let's go ahead and run our program. So we're going to run Python 3 server.py. So now it's going to tell me that it's waiting for a connection, and it outputs the time. So what I'm going to do on my client computer is I'm going to connect to the Pi through a Telnet connection. This is the Pi's IP address, and as I mentioned before, this is the port that the Pi is listening on. So let's go ahead and connect. The Pi recognizes that it's connected to my client computer, and it's also just checking for any files that may have been in the directory beforehand. So as you can see, it's trying to check this .python file, but it's not going to run it because we want our users to code in C. So the first thing that the client will say is hello, and the server is going to respond back, hello, welcome to our programming competition. If you would like a problem, please reply with problem. If you'd like to see the leaderboard, please reply with leaderboard followed by your initials. So let's go ahead and take a look at what the leaderboard looks like. My initials are MRD, so I'm going to type leaderboard MRD, and it's going to tell me that these are the top 5 and that MRD has not attempted this challenge yet. Okay, so that means we need to find the problem. Let's ask it for a problem. It's going to tell me that your problem name is test. Again, you will elaborate on this, so that way you could set it to be a sorting algorithm or depth first search or anything like that. It's going to tell me please code a solution in C. When you are finished, send me your file in zipper.tar format. And in order to do this, you're going to create a solution with a makefile and name the file with your initials and then the problem name.py, and then send the file over an SCP connection. It's going to tell the user what the guest password is. So again, we have set up the server so that it is secure in the fact that the guest user account cannot change any files on the Pi. It is only allowed to submit them. And it says, please be sure to check back later to see the leaderboard. Okay, so I'm going to exit out of my Telnet connection. Again, the server is still running. Now I've already gone ahead and coded up a solution. I put it into this zip file here, mrd_test.zip. So what I'm going to do is follow the instructions, and I'm going to SCP this file, which is mrd_test.zip, to guest at the Raspberry Pi's address. I'm going to put this in the directory where the challenge problems live. So I'm going to go ahead and do that. It's going to place it, once I put in the password, it's going to place it on the server. So now, if I connect again to the Raspberry Pi, you can see here that the Raspberry Pi has now run the file. So it connected to my computer again, it checked the zip file, it's telling me that it's processing it, it entered the directory where these test files live, it unpacked the zip file and made the file, makefile, for the C. It tried to pass the challenge, and it found out that the challenge did pass, and the score for me was 0.002, etc. seconds. So now, on the client, if I want to see my score, I'm going to check again at the leaderboard. I can see that now MRD is the fastest time, and it's telling me my rank is 1. And the Pi is ready for the next server. I hope you've enjoyed this presentation, and thank you.